Today we are going to spend some time looking at how to solve logarithmic equations. Now we've solved some logarithmic equations before by finding a common base on both sides, but that tool is not going to be sufficient today. Let's look at our first example. Log base 3 of 4 times x equals 17. We only have one logarithm. No matter what we do, we cannot make a logarithm on the right-hand side. Our solution is going to be converting this into exponential form. There's nothing outside our logarithm, so we can go immediately into finding our base, spiraling around, and saying 3 to the 17th power is equal to 4 times x. And then we're only one step away, and that is dividing both sides by 4. So 3 to the 17th power over 4. Now we could plug this into a calculator, but I can guarantee that 3 to the 17th power is a huge number. So rather than writing out possibly hundreds of digits, like I'm not sure if it'll be that big, we can instead just leave it in exact form. If we have a smaller exponent, such as 4 or 5, it might make sense to expand that product. But for an exponent as high as 17, we can just leave it 3 to the power of 17, all divided by 4. And that is our solution. Let's look at this example over on the right. We have the natural log of 5 plus the natural log of x equals 10. Now we have two logarithms on one side, but we can't make a logarithm on the other side. No matter what we do, it's not going to work. But we can't just go into exponential form right away. We have to condense our logarithms. Now hopefully you remember that when we add two logarithms together, we can condense them by multiplying their interiors, what we like to call the argument of a logarithm. And so we have the natural log of 5 times x equals 10. Now what is the base of the natural log? Hopefully you've been thinking of the letter e, which is really a number in this case. So we have e to the power of 10 is equal to 5x. And so to solve for x, we divide both sides by 5. So x is equal to e to the power of 10, all divided by 5. And once again, although we could more easily plug this into our calculator than 3 to the 17th over 4, we can leave it just like this as an exact answer. No further simplification necessary. Now there's one more type of logarithmic equation that I'd like to show us, and that's one that has some extra bits. So let's say, for example, 3, we have 2 times the logarithm, let's do the common log, so we won't write a base. 2 log x minus 1 is equal to, let's say 13. Now, in order to solve this equation, we have to isolate our logarithm. And we can do that this time by dividing both sides by 2. We have the common log of x minus 1, 13 over 2. And now that we have our logarithm by itself, we can transform it into exponential form. So our base of the common log is 10. So we have 10 to the power of 13 over 2 is equal to x minus 1. And so finally, we just add 1 to both sides. So x is equal to 10 to the 13 over 2 power plus 1. And once more, this is an exact answer. No further simplification is necessary. The only time it would be necessary is if this were an application in which we want a numerical decimal answer rather than an exact algebraic answer. And so these have been some examples of solving logarithmic equations by converting the expression into exponential form.